Okay, here's an interesting problem that says I've got some butane gas and I've got it in a tank. The tank has a pressure of 10 atmospheres and the temperature is 22 degrees Celsius. The tank has a pressure rating of 50 atmospheres. And if it gets higher than 50 atmospheres, then the tank will burst. We're going to say in a hypothetical situation that there was a fire and the gas got heated up to 500 degrees Celsius. What's the new pressure of the gas, and will the tank contain the gas without bursting? So this is what we call a two condition problem. A one condition problem is where I just say, here's some gas. Here are the conditions that the gas is experiencing. Calculate something about it. Here I'm saying the two condition problem is, here's a gas and the gas undergoes some change in its conditions, whether it's the temperature or the pressure or maybe both or something like that. And that's what makes it a two condition problem. Now in class, you should have come across the combined gas law. It was hopefully derived in class, but essentially what it says is that we can relate the pressure, volume, and temperature of a system, of a gas system under two conditions through this formula. P1 V1 over T1 equals P2 V2 over T2. So it's basically just saying that the number of moles of the gas stays the same. Now, let's take a look at the problem. What's the problem telling me? It's telling me that it's in a tank. If it's in a tank and the tank doesn't change its volume, then the volume is constant. That means that V1 and V2 are the same value. And if they're the same value, then in the combined gas law, they'll cancel out. So that allows me to simplify the equation a little bit to P1 over T1 equals P2 over T2. Okay, let's take a look. I've got P1 and T1, and I've got T2. So 10 atmospheres, 22 degrees Celsius, 500 degrees Celsius. And I've got 550 ATM. That's not the second pressure, that's the threshold pressure. So we're trying to get the second pressure and we're going to compare it to 50 atmospheres. If it's less than 50 atmospheres, then we're good, the tank doesn't burst. If it's more, then we're not good, the tank does burst. Okay, so let's take a look here. P2 equals P1 over T times T2 over T1 when I solve it for P2. Now, what's up with the temperatures? I've got temperatures in the numerator and temperatures in the denominator. So you might think that it doesn't matter what unit the temperature is in, but it actually does matter. And the reason is that in the Celsius scale, negative values are possible. And so the ratio of Celsius is not the same as the ratio of Kelvin. So we really do need to change it to Kelvin. And so we can't do this. And so let's go ahead and change the temperatures to Kelvin. So we've got 22 plus 273 and 500 plus 273. I get 295.15 with that one. And I get 773.15 with the bottom one. So let's put everything together. 10 atmospheres times 773.15 Kelvin divided by 295.15 Kelvin. When I put it into my calculator, I get that the second pressure is 26.2 ATM. So will the tank contain the gas without bursting? Well, it isn't over 50, so it will. And that's the pressure. So we've solved the problem. Okay, that's it.